You are most welcome to our today's class in mathematics, and today we want to look at a question in our Pearson Edexcel curriculum. And the question starts by giving us two very important functions, and I'm going to first write down the functions and be able to proceed with doing the question. So these are the functions the question has given us. So let's just start from here. So our first function is our function f that is in form of x, and that function is given as 4 minus 3x squared. And our next function is in form of g, and the most important variable in that function is x as well. And the function reads 5 over 2x minus 9. So these are two functions are going to help us work out some questions that actually been able to get brought down this question. And the first question is actually asking us to get function f and function g that are all in form of x. So you're supposed to take f and g in form of x. So what is the answer for this? And of course, they've given us the value of x as 2. So f g2. So that means the function of f times the function of g, where the value of x is what? Is 2. So what you're supposed to do is this. You don't even need to struggle so much about this question. First, get g2. The function of g, or the answer to the function of g, where the value of x in that function of g is 2. That's the hint behind that question. So just come and pick this function of g. They'll come here and say gx is equal to 5 over 2x minus 9. So this question came in one of the past examination papers. That was in 2024, which is just last year, and it was in the A-level mathematics paper. Okay, so the students were supposed to have actually understood that if two functions are to actually get multiplied, and one of the functions has a value of x, please first pick that function that has the value of x, where there's x in that function, substitute that value. So I'm actually trying to get g2. That means the value of x is 2. Yeah. So what do? I just come here and say 5 over 2 into, and what is x? 2. This x is 2. Okay. And we say minus 9. So this gives us 5 over 2 times 2 is 4 minus 9, that is minus 5. So that gives us minus 1. So let's get back to the question. It has to read FG2. And literally, then that means we are supposed to say F, then G, then 2. But the good thing is this. We know very well F, then G2. What is our G2 as our answer? Negative 1. So we're going to have negative 1 here as the answer of G2. So then what do? We know that the function of x is 4 minus 3x squared. So then that means where there's x in this function of f, you're supposed to put minus 1. So we shall have 4 minus 3 into negative 1, then squared. So it will be 4 minus 3 into 1. That translates into 4 minus 3. So the answer is 1. So I first got G2 as negative 1. I came back and said, in the equation f then G2, I'll say f then G2. I know G2 is negative 1, so f then negative 1, the answer of G2. So in the function of f, where there's x, I just put negative 1. So just say 4 minus, where did I get this equation or this function? Is the function of f in terms of x. So 4 minus 3 into negative 1, now the value of x, which is now the value of g2. You see, and I just square this and multiply by 3 and minus 4. I'm going to get 1 as my answer. So the function of f times the function of g, where the value of x in the function of g is 2, is going to be 1 as our answer. Okay, the second part of that question was, okay, that was now part 1. I've actually captured that. So part 2 was actually asking us to get this. So the inverse of g. You're supposed to get the inverse of what? Of g. Then you're supposed to first to capture that function. So you're supposed to say g, then x is equal to 5 over 2x minus 9. The function of g in form of x, you see, is 5 over 2x minus 9. So what I'm supposed to do is this. I just come here and be able now to ask myself a very simple question. This gx is also the same as y. Just like the way you can be able to say fx is y. The same thing. No difference. You see. So gx is the same as y. So you come here and say y, now gx, okay? You can only be able to get the inverse of a particular function if you have both x and y, representing the y and the x-axis, of course, of the Cartesian plane. But the form in which any equation can appear, whether quadratic equation or linear equation. So y is equal to 5 over 2x minus 9. Then what do I do next? I eliminate the denominator. Then what do I do? What am I even doing here? I want to make x the subject of the formula and not just y, as per the question has already been able to give me. So I want to make x the subject of the formula. So I'll have this. I'll say times 2x minus 9, then times 2x minus 9. So the first thing, always pick that part of that function and replace it with y, equal to that function, as what you've actually been given in the question. Try to rearrange so that now you can be able to make x now the subject of the formula, the next step. So you can now have y is equals to this. So 2x minus 9, then we have y, then this is equals to, so this and this will disappear. So you shall have 2x minus 9, okay, then into y should be equal to what? To 5. Then next, I can open the brackets. 2xy minus 9y is equals to 5. So I'll take 9y on this side. So I'll have 2xy is equals to 5 plus 9y. Then next, I'll divide all through by what? By 2y divided by 2y. So I'm going to have my x as 5 plus 9y over what? 2y. So you see, I've made now x the subject of the formula. And of course, the last step is now to swap the x and the y. So I'll take back my y, then take back my x. So that I'm just going to have now y again is equal to. So in the place of x, I put y. In the place of y, I put x. So y is equals to 5 plus, then I'll say 9x, and again not 9y. Then I say over 2x. So that means my g inverse in form of x, or in terms of x, the inverse of g as a function in terms of x should be equal to 5 plus 9x over 2x. Now, what was the main aim of swapping at this point? Because the inverse of that function should be in the form of x, so you can't be able to leave y here and write that equation here as your answer. It cannot even work. So what do? You first do the swapping so that your final answer can only be able to have the x, because the getting of the inverse of this should be in form of x and not in form of y. So then you can be able to say 5 plus 9x over 2x. So that becomes the inverse of the function g in terms of x. Yeah, so, and the last part was actually asking us to get this. Let me see. They were asking us to get, what was it? It was actually gf in form of x. Look at that. So they want us to get that g in form of x. So what do? We know very well the function of f is this, the function of g is this. Don't even bother so much about this. You know very well g, the function of g, is getting multiplied with the function of f in terms of x. So I'll just take fx and substitute in the function g. You see? So I know very well the function of f in terms of x is this. The function of g in terms of x is this. So I'll just come here and say function of fx is 4 minus 3x squared. So that means I'm going to pick this function of f in terms of x, then I substitute in the function of g. You see, because it is g then fx. What is fx? 4 minus 3x squared. But now the 4 minus 3x squared, the function of f in terms of x, should be substituted in the function of g. So just come here and say, where is the function of g? It is here. Function of g is 5 over 2x minus 9. So I'll just come and say 5 over 2x minus 9 is the function of g. Then I'm going to pick that function of f in terms of x. I substitute in this function of g. How? Where there's x, I put that because it is gx. But now we don't have an exact value of x. We have a function. So instead of putting now this x here again, I'm going to pick this value. I put in that space where there's that x. Because now this 4 minus 3x squared represents now our x. You see? So it is g then this, gx. So that means g, the function, then x. In this case, is going to be 4 minus 3x squared, the function of x, or the function of f in terms of x. So we'll come here and say 5 over 2 into. You see, we always say this. If it is g, then this function. That means where there's x in the function of g, I'll put the function of x. That is what it means. So gf then x. So g then fx. So where there's x in the function of g, I put fx, the function of f in terms of x. So g then the function of f in terms of x is here. So gx, that means in terms of where I have actually x, that function, I'm going to put that function of what? Because this serves as our x. This 4 minus 3x squared, the function of f. So that's what I've actually just said. The function of g is here, 5 over 2x minus 9. Now what is x? For this function of g, it is the function of f, which is this. So this becomes our x. So where there is x, you are going to put that. So you're going to take 4 minus 3x squared to put where there's what? X in this function. So 2 into, we have function of f, which is 4 minus 3x squared. Okay, then we say minus 9. We shall proceed and have 5 over 2 times 4, that is 8. Then minus 6x squared. Okay, just a minute. 8 minus 6x squared. Okay, then minus 9. So I'll proceed and have 5 over, I'll collect like terms, 8 minus 9 minus 6x squared. So I'll have 5 over minus 1 minus 6x squared. I'll rearrange. So I'll have my final answer as 5 over minus 6x squared minus 1. So that becomes now the function of g, the function of f in terms of x. So that becomes our final answer for that third part of that question. Thank you so much for your